All right, so this is section 1-4. This is called properties. Let's move on. All right, and so we need to understand what the properties mean. The first property that we have is called the commutative property. And for commutative property, we have what's called the commutative property of addition, and then we also have the commutative property of multiplication. And so I have each of those shown. The top example is the commutative property of addition because you are adding. So we have 2 plus 3 equals 3 plus 2. All we're saying, this is a property just to show you that you can flip the order, change the order of these, and it doesn't change the value. We know that 2 plus 3 equals 3 plus 2, and it doesn't matter which one you say first. And then we do the multiplication one. 2 times 3 equals 3 times 2. Obviously both of those is equal to 6. But again, the commutative property says that we can change the order of those, and it doesn't really change the answer. They're both equal. So that is called the commutative property. And next we have what's called the associative property. Again, there is an associative property of addition, and there's also an associative property of multiplication. The addition is when you're adding, the multiplication is when you're multiplying. And so the top example, 5 plus 8 in parentheses plus 2 equals 5 plus 8 plus 2 in parentheses. And again, just like the commutative property, we're just showing that both sides are equal. So we can add the 5 plus 8 first, which is 13, and then you add 2 to get 15. Or you can do it in a different order. You add 8 plus 2 first, which is 10, and then you add 5. You still get 15. So all they're doing is showing you that this is something you can do. It doesn't change the final answer. You're still adding 5 plus 8 plus 2 and 5 plus 8 plus 2, but you do it with parentheses around something different, which means you do parentheses first and then the other part, but you still get the same answer. The bottom one is multiplying. So we have 4 times 6, which is 24, and then times 3, which is 72. And I bet you we'll get the same thing on the other side. We still have 4 times 6 times 3, but parentheses are around something different. So in the second part, we do 6 times 3 first, which is 18, and 4 times 18, again, is 72. So no matter which way you do it, you still write them in the same order, but you do it in a different order because of the parentheses. But no matter which way you do it, you still get the same 15 or 72. Next property is called the identity property. This is kind of funny, but what happens in each of these, you've got the addition, the identity property of addition. There's 2 examples there. You've got 5 plus 0 equals 5, and 0 plus 9 equals 9. All it's saying is to keep the identity of the number 5, if you can add a number and still remain 5, that number is 0. And then in the same one on the other side, if you take 9 and you add 0, you still get 9. So the 9 and the 5 kept their identity by staying and remaining the same. All right, and then you've got the identity property of multiplication. And multiplying by a certain number, how do you keep the number 7 to be equal to 7? Well, you multiply by the number 1. 7 times 1 is 7, and in the other case, 1 times 6 is 6. So you can add 0 to keep identity, or you can multiply by 1 to keep identity. The top one is the addition part, and the bottom one is the multiplication part. And the next property is called the multiplication property of 0. And you see that on page 44. Guys, we're not trying to teach you math here necessarily, because we all know these answers are pretty simple. All they're teaching you is the name of certain properties. And in this case, when you multiply by 0, you always get the answer of 0. 4 times 0 equals 0, and 0 times 2 equals 0. So that's just called the multiplication property of 0. It's just the name, something important to know. All right, now example 1 says to name the property shown by each statement. So letter A has 3 plus 7 plus 9 equals 7 plus 3 plus 9. So you're just trying to figure out which property are they talking about. Well, what you should notice here is The plus 9 stayed in the same spot, but 7 plus 3 and 3 plus 7, the order got switched. So that is called the, oops, missing an M, commutative property of addition. All right, this pen is kind of hard to write with, but it should be commutative property of addition because of those things changing. So that's what you got to notice. Part B, it has a times 6 times 5 on both sides. It's the same order, but the parentheses are around something different. But because you're multiplying, in this case it's known as the associative, A-S-S-O-C-I-A-T-I-V-E. All right, associative property of multiplication. All right, example 2 says to find 4 times 25 times 11 in parentheses mentally. So what that means is they're asking you to understand your properties you just learned. Now 25 times 11 might not be something you can do in your head, but 4 times 25 is something you can do in your head. So what they're teaching you is when you know the associative property and you know a place where you can use it, just switch your parentheses around and do 4 times 25 first, which is 100. We're still following PEMDAS here. And 100 times 11, that's a little bit easier. It's 1 times 11 with the 2 zeros here. All right, so you end up with 1100. Got that mentally without having to do the math on the side here. All right, that's what we're trying to avoid when it says to do this mentally. All right, so example 3 here says, is subtraction of whole numbers associative? If not, give a counter example. And so what I want to teach you here is what a counter example is. Can you do subtraction in the associative property? All right, so here's your example. 3 minus 5 minus 2, does that equal 3 minus 5 minus 2? And then what you should notice is we have different things in parentheses. So this is the counter example to prove that statement is false. So that's what a counter example does. It proves that a statement is false. So that's what we do. 3 minus 5 is negative 2. And then we drop down the other minus 2. On the other side, we've got 3 minus, and then we do what's in the parentheses. 5 minus 2 is 3. As you can tell after one step, these are not the same thing. We'll learn this later in the year, but negative 2 minus 2 is negative 4. It's not negative 0. If you think it is, well, you'd be wrong, and I will be showing you in a few weeks why it's negative 4. And then on the other side, 3 minus 3 is equal to 0. So here is a counterexample that proves that subtraction of whole numbers is not associative. You can't do it in subtraction, and you can't do this in division. You won't get the same numbers. The only time associative property or commutative property work is when you're adding or multiplying. All right, so starting with example 4, we have to simplify each expression. So we're going to learn what simplifying means. We're just going to condense this down into its simplest terms. So we start with a couple notions here. So we start with parentheses, k plus 2. Well, k plus 2 should stay k plus 2 because technically we can't put those together. They are not like terms, all right? But we do know by the associative property, because we just learned this, that we can actually, because these are all adding, we can change the parentheses to be around 2 plus 7. I'm running out of room. 2 plus 7 instead. All right, so we can do 2 plus 7, which is 9, and then we drop down the k. Remember, you can't put those together. They're not like terms. K plus 9 is not 9k, all right? They're not multiplying. All right, so you actually just leave it as k plus 9. That is the answer for this in simplest terms. All right, so we simplified it. And the next one, kind of the same concept here. We can switch a couple things around. We can actually do d times 9. D times 9 is 9d. And it's still multiplying by the 5. And if you have 5 sets of 9d, you actually have 45d. Now, that doesn't really include any of the properties we just learned. The property they show you in the book is switching the d and the 9 and making it 9 and d. So they would do something like this. Times parentheses d times 9, they change it to 5 times 9 times d. So they switched 9 and d, or d and 9, and made it 9 and d. And then what they did was use the associative property next. So they just used commutative to switch 9 and d. Now they use associative to change where the parentheses go. Right? And you can only do this when you're multiplying or adding. You can't do this in subtraction or division. So we flipped the parentheses around, we flipped the 9 and d around. Now we can do the parentheses here. All right, this is just getting technical about the properties and understanding them, but ultimately you still get the same thing I just showed you a little bit ago, which is 45d. And the last concept we have is the last vocabulary term in that section. It's called deductive reasoning. And just to kind of put it all together, everything we just did in this section is called deductive reasoning. We're using facts to be able to come up with answers and solutions for problems. And how this is different is in section 1 we learned about inductive reasoning. Inductive reasoning is using a pattern of events from a past to make a conclusion. But in this case, deductive, we don't have past events, we actually have facts, properties, or rules that we use to reach a conclusion, so we know for sure based on the facts that it's a certain way. Inductively, we use patterns and we say, well, we think it'll be this based on what the past showed. All right, so that's all our vocabulary. That is section 1-4. Best of luck.